Okay, so basically we said that x bar is equal to 1 over n times sigma x of I f of I as I goes from 1 to n, where basically where sigma f of x of I f of I, where sigma x of I f of I as I goes from 1 to n denotes the sum of the products of observations x of I with the respective frequencies f, where this denotes the sum of the products of observations x of I with their respective frequencies f of I, and you know what that means because I showed you that example, and n is equal to sigma f of I as I goes from 1 to n, then is the sum of the frequencies. So then we find the deviations of observations x of I from the mean x bar. So then what we do is that so that way basically you can calculate x bar, and so then we find the deviations of the observations f of x of I. We find the deviations of the observations x of I from the mean x bar, and take their absolute values that is the absolute value of x of I minus x bar for all I is equal to 1, 2, all the way up to n. And after this, it's basically the same procedure that we did. We basically, the only thing that we did here, we introduced some more, basically a more convenient way to basically calculate x bar. That's basically all we did here. So after this, find the mean of the absolute values. After this, find the mean of the absolute values. The mean of the absolute values of the deviations which is the required mean deviation about the mean, which is the required mean deviation about the mean. Thus, you can say that the mean deviation about the mean is the same thing as basically finding so we said that your x bar, you can calculate it as so you can write that as basically x bar, you can calculate it as basically 1 over n sigma x of I f of I as n as I goes from 1 to n, right? So now what I need to do is that I need to write, I need to take, basically I need to find the deviations of the observations x of I from the mean x of x bar, and then take their absolute values. That means that I need to find the absolute value of x of I minus x bar. So x of I minus x bar, and then so that means that I have to calculate the sigma of the absolute value of x of I minus x bar as I goes from 1 to n, and then divide by and then divide by basically, then after this find the mean of the absolute values of the deviations, which is the required mean deviation. So then I need to just multiply this, divide this by n. Now you know that your x bar is equal to I don't know why this has been multiplied by f of I. So that's 1 divided by n sigma f of I times the absolute value of x of I minus x bar. So there is something here that I don't understand. And now what they have done here is that they have written this as, so this is the mean deviation about mean. So this is the mean deviation about mean. Okay. Now what they have done is that they have written this as basically 1 divided by n. So basically that's the same thing that we have here, times sigma f of I times x of I minus f of minus x bar as I goes from 1 to n. And we do this, you can do this, and if you do this, then you don't have to basically, excuse me. Okay, so when you do this, you don't have to suppose that, for example, you have all of these different x of i's. For example, you have, for example, 2, 3, 5, 2, 7, 2, for example, 17, 19, 2, and so on and so forth. And you have a couple more, for example, or these are all the observations that you have. So if these are all the observations that you have, then of course suppose that you calculate x bar using this formula here, right? So that's no problem. Now, once you calculate x bar here, then you are required to calculate the distance or the difference of each x of I from your x bar, meaning that every time you have one observation, you have to take your observation, for example 2, and find the difference of that observation and x bar here, and find the, of course, take the absolute value of that. Again, you have basically, for example, 3 over here, you have to do the same thing. 3 minus x bar, take the absolute value of that. You have 5 minus x bar, take the absolute value of that, and so on and so forth. So of course it makes sense that, for example, if you have, for example, 2 repeating, for example, 4 times, instead of doing this 4 times, I can write 4 times, for example, 2 minus x bar, and that takes care of this, that takes care of basically me doing this 4 times. I can write this 1 time, and then the whole thing will be taken care of. That's why this f of I is over here, and this f of I, of course, basically refers to the frequency of this 2 happening here, which is 1, 2, 3, and 4 times. So 4 times, for example, 2 minus x bar, and that's the formula that you can use there. That's the reason why they have written it this way. And so, but of course you usually do this in tables, in basically separate tables. So in a table you calculate all of your basically f of I times the absolute value of x of y minus x bar, and so on and so forth, and then you take you find the sum of all them. You write the sigma f of x of I in the bottom of the table, and then you calculate that, and then you can of course divide the whole thing by n. So then basically in conclusion you can say that the mean deviation about mean of a set of observations, you can write it as 1 divided by n times sigma f of I times the absolute value of x of I minus x bar as I goes from 1 to n, and that is the formula that you can use there. And that is the formula that you can use there. On the other hand, if you want to calculate your x bar, your x bar is basically 1 divided by n, sigma x of I f of I as I goes from 1 to n. That is also useful in such cases. So these are basically the two simple things that you can use in order to find the mean deviation about mean in case of basically some observations that you might have. Now the next thing that we have is the mean deviation about median. Now, in order to calculate the mean deviation about median, it's basically again the same process. The only difference is that instead of basically over here, we said that we had the mean deviation about median, for example, here. That was about that is actually about that. This is wrong actually. This is this is not, this is actually the mean deviation. This is the mean deviation about mean, because x bar refers to your mean, the mean of your data. Okay. Now, the only difference that you might have, if you think about that logically as well, of course you would come to the same conclusion, that you would have the same kind of basically process for your median, except that in this formula somehow you need to find your median, the median of your data, which is denoted by m, the median denoted by m. So this is median denoted by m, and so the only difference is that in the mean deviation from median, that would be the mean deviation about median. That would be basically 1 divided by n, the sigma of basically f of I times the absolute value of x of I minus m as I goes from 1 to n. As I goes from 1 to n. So the mean deviation about median would be basically this. So it says that to find mean deviation about median, we find the median of the given discrete frequency distribution. Now, discrete frequency distribution, I don't know what is meant by that, but it's some sort of table basically. It's not that big a deal. For this observation, for this, the observations are arranged in ascending order. After this, the cumulative frequencies are obtained. Then we identify the observation whose cumulative frequency is equal to or just greater than n divided by 2. Then we identify the observation whose cumulative frequency is equal to or just greater than n divided by 2, where n is the sum of frequencies. This value of the observation lies in the middle of the data, therefore it's the required median. So that's basically how you find your median. You know how to find your median. I gave you basically 3 formulas for that. And when we go through some example, you will know what this means. And then after finding median, we obtain the mean of the absolute values of the deviations from median. Thus, the mean deviation about median is equal to 1 divided by n, the sigma f of I times the absolute value of x of I minus m, as I it goes from 1 to n. And that's basically the whole story there. So now let's do a couple of examples. Let's see what we have here. So now example number 4. Example number 4 is some table we have here. Okay, so now let's find the mean deviation about the mean for the following data. So your data is basically, you want to find the mean deviation. You want to find the mean deviation about the mean. About the mean. Okay. So what you can do here is that, of course, the data first of all is this is your x of I, and this is your f of I, and if you form a table of this, you have a 2, you have 5, 8, you have 6, 10, you have 8, 7, you have 10, 8, you have 12, 5. So what this means is that you're basically the number of observations that you had, and from those observations, then you have basically formed this table is that the number of those observations have been basically 2 plus 8 is equal to 10, 10 plus 10 is equal to 20. This is a 15, so 35 and 40. So that means that you've had 40 observations, like 1, 2, 3, and so on and so forth, and in such a way that the number of those observations were 40. And for example, over here you had the 2 times. You had 5 8 times, so 5 5 5 5 5 and so on and so forth, 8 times repeating. So then we have taken x of I as 5, and then the frequency of that has become 8, meaning that we had basically 8 5s repeating we had basically 8 5s what do you call it, observations, and then based on all of this data, basically then you've got this table over here. Now what you want to do is basically you want to find the mean deviation about the mean. That means that you want to find the mean deviation about the mean, and the mean is x bar, right? So that is the same thing as 1 over n times sigma of basically f of I times basically x of I minus x bar as I goes from 1 to n. That's basically the formula that we developed. And so you do need to basically find, you do need to calculate all of this. Now the way that you can do it is that you need to create a table based on the table that you have, and then what you usually do, you take a look at the formula and see what you need to be calculated in the formula. You add it to your table, meaning that usually you do a table like this, and for example you call this, for example, your, I don't know, x of I, for example, and then you call, for example, this is this f of I, for example, and we said that basically to calculate your x, we do need to calculate the x bar. So the x bar is basically equal to, what do you call it? It's equal to 1 over n sigma f of I x of I as I goes from 1 to n, right? So for this formula, for example, we need f of I times x of I. So I write it over here, f of I times x of I. And then we need basically x of I minus x bar. I need x of I minus x bar, and of course the absolute value of that for this part of this formula. So everything that you need here, you need to calculate to put it in a table so that you can access it later. And then we need to multiply f of I by this thing over here. So I write f of I times the absolute value of x of I minus x bar and put it over here. And that's most probably everything that I will be needing. Now the x of i's, you can take them from here. So you have basically 2, 5, 6, 8, 10, 12, 2, 5, 6, 8, 10, and 12. And the f of i's related to these x of i's are 2, 8, 10, 7, 8, and 5. Now f of I times x of I, you can just simply multiply these together. So 2 times 2 is equal to 4, that is 40, that is 60, that is 56, that is 80, and that is 60, right? Now you need to calculate x bar. So x bar is equal to, let me calculate it here. So we said that x bar is equal to 1 over n times sigma f of I x of I as I goes from 1 to n. So that's equal to 1 over the number of the observations is basically the number of the observations is not basically, you cannot basically count these numbers over here, 2, 5, 6, 8, 10, that would be 1, 2, 3, 4, 5, 6 numbers, right? That's not the number of your observations, because you know that, for example, 2 has been repeated twice, 5 has been repeated 8 times, 6 has been repeated 10 times, and so on and so forth. So what you need to do is calculate the total number of times that all of your observations have occurred, okay? And that you could call sigma, f of I, meaning that you're adding all of these f of i's together. So that's 2 plus 8 is equal to 10, 10 plus 10 is equal to 20, 20 plus 15 is 35, and that's equal to 40. That's basically, for example, sigma f of I. Now sigma f of I, you can take it as n, because that's again the total number of times that your individual basically individual basically observations have occurred. So that's 1 over 40. That's 1 over 40. And then sigma f of I times x of I is we can calculate it from here as I goes from 1 to n. So you can calculate that. Let me see. Okay, so now again, based on this table, you can calculate sigma f of I x, sigma f of I x of I, sigma f of I x of I as I goes from, for example, 1 to n, which would be all of these f of I x of i's added together, which is basically, so for example, here you have 104, and then you have 56, that is 140, and then you have 56, so that's a 0, 1, that's a 0, 1, that's 300. That's 300. So that is 300 divided by 4 times 300. So you can calculate, you can simplify this 4 and 30 and divide by 2, you will get 15, and divide by 2, you'll get a 2. That's 15 halves. So your x bar is 15 halves. This is equal to 15 halves. I suppose, if I'm not, 7.5, okay. So they've taken this as 7.5, but I'll just leave it as 15 halves, see what happens. So now what I need to do is calculate basically x of I minus x bar and take the absolute value of that. So x of I is basically this observation here minus, I take this as 7.5 because I want to do basically, I want to subtract. So 7.5 minus 2 is equal to 5.5. So I write it as 5.5. That's actually 2 minus 7.5 is negative 5.5. The absolute value of that is 5.5. 5 minus 7.5 is 2.5, is negative 2.5, so that's positive 2.5. Negative 1.5, so that's positive 1.5. 8 minus 7.5 is 1.5, is 0.5. 10 minus 7.5 is 2.5, and 12 minus 7.5 is 4.5. Is 4.5. This is not 4 times 5, this is 4.5. Okay. Now, f of I times basically x of I, the absolute value of this whole thing. So you have to multiply this thing by this thing. So 2 times 5.5 is 11, and 5 times 2.5 is equal to 5 times 2 is equal to 10, and this is 2.5, so 12.5. 6 times 1.5 is 6 and 9. 8 times half is equal to 4. 10 times 2.5 is 20, and 10 times half is equal to 5, 25. And 12 times 4.5 is equal to 48, and 48 plus 6 is equal to what? 48 plus 6 is equal to 14, 54. Don't want to make mistakes, so let me check 12 times 4.5. 12 times 4.5 is equal to 54. So that's basically this part. And then you need to calculate sigma f of I times the absolute value of x of I minus x bar. So you need to calculate sigma f of I times the absolute value of x of I minus x bar as I goes from 1 to n, right? Which is the sum of all of these numbers. So this is basically 23.5. This is 23.5. This is 13. This is 25. And this is 54. So you have 5 here, or 0.5 here. There is 6. 6 plus 9 is equal to 15, 1. And then you have 3, 4, 6, and 11. So that's 115.5 is equal to 115.5. Okay. So now there is something wrong here. 4, 40, 60, 56, 80, 60, and then you have 5.5, 2.5, 1.5, 0.5, 2.5, 4.5, and then f of I 11, 20. This is not supposed to be 20. 8 times, okay, 8 times this number is 16, 20. This is, of course, this is 20. Why? This is 20. And then you have 15. I have made a mistake here. 10 times 1.5 is 15. I must have multiplied something else by something else. 7 times 05 is 3.5. Is 3.5. 8 times 2.5 is equal to 16. And 4 is 20. This is supposed to be equal to 20. And 5.4 to 20. 22.5. Right? 22.5. 22.5. So this number is actually not correct. So you have 31 plus 31, 46, and you have 20, 40.5, and 3.5. This is 0, 1, and 0, 1, and that's 8, 9, 90. This is 90. 22.5, 23.5, 15, 20, and 11, as it's supposed to be. So you have 11 plus 20 plus 15 plus 3.5 plus 20 plus 22.5. 92. Okay. 92. So now this number is 92, right? So now in order to calculate basically the mean deviation about mean, which is the mean deviation about mean, what you want to do is 1 over n. So n is basically, again, sigma f of I, which is 1 over 40. 1 over 40. And sigma f of I, x of I, sigma f of I times times the absolute value of x of I minus x bar, as I goes from 1 to n, is, we found that to be 92. So times 92. So if I divide by 2, I get 46, divide by 2, I get 20, divide by 2, 10, divide by 2, 23. That's 2.3. That is 2.3. So now what this means, what this number actually means, is that basically you can see that your numbers go from basically 2 all the way up to 12. That means that on a number line, basically, if you go, for example, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And so at 2, you have basically 2, the frequency is 2 at 2. So you will get, for example, 2 such points here, meaning that you have 2 observations here. At 5, you had 8. 1, 2, 3, 4, 5, 6, 7, 8. At 6, you have 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. At 8, you have 7. So 1, 2, 3, 4, 5, 6, 7. At 10, you have 8. 1, 2, 3, 4, 5, 6, 7, 8. And at 12, you have 5. So 1, 2, 3, 4, and 5. Now, the mean of these numbers, we found that to be 7.5. So 7.5 here, x bar is equal to 7.5. That's, as you can see, it's exactly between 2 and 12. 1, 2, 3, 4, 5 units. 1, 2, 3, 4. Well, not exactly between the two observations and number line, but adding all of these observations together and dividing, you would get 7.5. That's your, because it's not exactly between 2 and 12. So you have 1, 2, 3, 4, 5 units here, and 1, 2, 3, 4 units. So it's not exactly between the two, between the minimum and maximum, but it is somewhere in between, meaning that this value is important. This value comes from basically all of these observations added together and divided by the number of them. So of course it makes no sense to expect that the number comes exactly between these, the minimum and maximum of all the observations. Okay. Now what this means is that now the mean deviation about mean happens to be 2.3. So 2.3 would be basically, for example, somewhere over here or somewhere over here. That means that now this number is based on how these observations are scattered around your mean. Now, once you work a little bit with real data and take a look at these numbers, then basically these numbers start making sense to you. In basically you will start understanding them in a certain way. And then basically if you see a number for your mean deviation, for example, about mean, then you will be able to form some idea in your mind of or some sort of idea in your mind about basically how all of your observations are basically are scattered around, for example, the mean or the median or whatever it is that you have calculated, for example, for your data. And so, for example, then, so that's basically how you solve this kind of problem. And we have another question over here. We have another example over here. So let's say that you have let's say that you have some data here. Let's say that you have, for example, you want to find the mean deviation above the median. You want to find the mean deviation about the median, meaning mean deviation about the median. About the median is basically represented this way for the following data, and the data that you have is basically this. So you have your x of i's and f of i's and everything in this way listed here. So this is your x of I, this is your f of I, and then you have, for example, 3, 6, 9, 12, 13, 3, 6, 9, 12, 13, 15, 21, 22, 15, 21, 22, and 3, 4, 5, 2, 3, 4, 5, 2, 4, 5, 4, 3, 4, 5, 4, 3. That is your data. And you want to find basically the mean deviation about the median for this data. Okay, so now in order to calculate the mean deviation about the median, here what you need to do is, of course, first calculate the median. And so of course you know that to calculate the median of these numbers, what you need to do is well, it's a little bit different than if you had basically your numbers just simply written out, because but of course that's not a problem. That is not a problem, because CF cumulative frequency is 3, 7, 12, 14, 18, 23, 27, and 30. Okay, so there is something called the cumulative frequency, which you so basically if I calculate sigma if I calculate sigma f of I in this case, it's going to be, for example, something like 7 plus 5 is equal to 12, 14, 16. 16 plus 5 is equal to 21. 21 plus 7 is equal to 28. That means that I have 28 observations. And since this is a even number, so of course then my median is going to be basically n divided by 2th observation and n divided by 2 plus 1th observation, meaning that n divided by 2 is 14th and 15th observation. So 14th and 15th, then you need to add these numbers together to see where you get to 14 and 15, for example. So, for example, here you have 7 plus 5 is equal to 12. 12 plus 2 is equal to 14. And so that's the 14th observation, and the 15th observation comes here, meaning you get most probably 12 and 13, something like this. Let me see. It seems that both of them end up in 13. Now let me see what I did wrong. N divided by 2th is basically 20 divided by 15th and 16th is supposed to be right. Maybe the number of observations I have probably made a mistake there. So I have 3, 4, 5, 2, 4, 5, 4, 3. So that is 7 plus 5 is equal to 12, 14, 18, 18, 23, 23 plus that's 30. That is actually 30. So if you have 30, if your sigma f of I is equal to 30, then again n divided by 2 is 15th, is basic 30 divided by 2 is equal to the 15th observation, and then the 16th observation, and the 16th observation. Now the 15th and 16th observation are going to be over here. So that's a 7, 12, 14. So then you have your 15 and 16 over here. You have 15, 16, 17th and 18th observation here, because you have 4 observations here. And so 15 and 16 are going to be the same number, 13. So that means that the 15th and 16th observations are going to be basically this x of I, which is equal to 13. Okay. Now this way of calculating your median is of course fine, as long as you have just a limited number of basically x of i's, and then you could basically do the calculation manually, adding the numbers together, and you get your observation, your median, for example, that way. Now when the number of observations basically gets a little bit higher and it gets a little bit more complicated, then it's not that easy to find the number of to find your median that way. So for the same reason, what they have done is something called the cumulative frequency. Cumulative frequency and I'm not sure if I actually remember how that worked, but I will try to remember that. So the cumulative frequency is called CF. Now, the way that you get to cumulative frequency related to some observations, actually there were two types of these kinds of frequencies as far as I can remember. Now let's see if we can actually get to this one first. So the cumulative frequency of your data in this particular case, for example, is not that complicated. So you start with the frequency of your data over here, which is basically of this observation over here, which is 3. And then when you get to the next x of I, you have to add this number, whatever that is, to the next basically frequency, which is 3 plus 4 is equal to 7. Again, 7 plus 5 is equal to 12, 14, and 18, and 23, for example, 27 and 30. And as you can see, the frequency is, well, cumulative. It is cumulative. Cumulative, meaning that as you go along the way, it adds up to itself and adds more and more and more until you get to the last, basically to the last, for example, row or column, whatever you want to call it. Now, the way that you can use the cumulative frequency to find the median of your data easily is that you need to, we read something about it over here, although I didn't really understand it when I read it, which was basically to find what we read about the cumulative frequency was that to find the mean deviation about median, we find the median of the given discrete frequency distribution. So I suppose this table is called basically discrete frequency distribution. This table, this part of the table, I suppose it is called discrete frequency distribution. Now, of course, I might be wrong about this, but most probably it is, well, it is not wrong. And whatever, I mean, it doesn't really matter whether that's correct or wrong here. Basically, you have your data in some manner, for example, in some table. Now, suppose that, for example, if you put your data in a certain way together in a specific kind of table, that would be called, for example, the discrete frequency distribution. Now, I don't want to basically go back and look all of these up because that would take a whole lot of time. Now, for this, the observations are arranged in ascending order. As you can see, the observations have been arranged in ascending order: 3, 6, 9, 12, 13, 15, and so on and so forth. After this, the cumulative frequencies are obtained, which is basically this part over here. Then we identify the observation whose cumulative frequency is equal to or just greater than n divided by 2. So of course you have to go for n divided by 2 because the number of observations, which is sigma f of I, that is equal to n, right? You can take this as n. And so then based on this, n divided by 2 is equal to, for example, 15. So now the cumulative frequency of for example, if I go for this column over here, you can see that the cumulative frequency is 14. So it's not going to be useful for me right now, because I want the cumulative frequency of that column to be equal to or greater than or greater than n divided by 2. Now n divided by 2 is equal to 15, so I have to go for the next basically column after this column, which is basically this column over here. And of course, since I'm looking for the 15th and the 16th observations, of course they fall within this column over here, and so that way you know that the observation that you're looking for, which is the median of your data, is 30, right? And if you paid attention, that of course the first time that we kept basically adding these numbers up together, we got to the same column over here, and then based on that we wrote that basically the 15 and 16 observation both would be the observation which is 13. X of I is equal to 13. And so it says that then we identify the observation whose cumulative frequency is equal to or just greater than n divided by 2, which is what we did over here, where n is the sum of frequencies, sigma f of I. This value of the observation lies in the middle of the data, therefore it's the required median. So this value of the observation lies in the middle of the data, and therefore it is the required median. After finding the median, then we obtain the mean of the absolute values of the deviations from the median. So that's basically what we had next. So over here we have, so once you basically set up your table like this, now your n is equal to 30, which is an even number. The median is the mean of the 15th and 16th is the mean of the 15th and 16th observations. I forgot to tell you this, and I had actually forgotten this. When the number of when your n is an even number, when sigma f of I, which is equal to n, is an even number, then the observations that come exactly in the middle of the data, then the observations that happen to fall exactly in the middle of the data, in the middle of all the observations, basically sorted out in an ascending order, which is essentially the median of your data, will be given by basically n or basically n divided by 2, n divided by 2th and n divided by 2 plus 1th observations. Now since we need only one basically observation as the median of the data and not 2, we need to calculate the mean of the two observations and then call that mean the basically the median of the data. So what that means is that you're not basically over here, since your sigma f of I is an even number, you get basically n divided by 2th observation and n divided by 2 plus 1th observation, which would be basically 2 observations here. And of course you need the median of your data is going to be it needs to be only 1 observation, not 2 observations, meaning that you have 1 median, not 2 medians. So now, in order to solve that problem, what statisticians have done and what mathematicians have done is that they have agreed upon this, upon basically taking the 2 observations and basically finding the mean of those 2 observations. The mean of those 2 observations will be called the median of the data, which will be only basically then one single number. And so now in this case, in this particular case, what we have is that the median is the mean of the 15th and 16th observations, and both of these observations lie in the cumulative frequency 18 here, for which the corresponding observation is 13. Therefore, the median m, therefore you can say that the median denoted by m is equal to the 15th observation. So the 15th observation plus the 16th observation divided by 2, which is equal to 13 plus 13 divided by 2, which is equal to 26 divided by 2, which is equal to 13. And that is the median of your data. So now what you need to do is find the rest, basically solve the rest of the problem. Now let me erase all of this. We don't need them anymore. Okay, so next what you need to do is that, so you know that your median is equal to 13. So m is equal to 13. M, which is basically the median, is equal to 13. So now basically we wanted to calculate the mean deviation about the median, which means that we do need to calculate basically the mean deviation about the median, meaning the mean deviation about the median is going to be 1 over n sigma f of I, the absolute value of x of I minus m as I goes from 1 to n. So first I need to calculate the absolute value of x of I minus n, and then basically f of I times the absolute value of x of I minus n. So what I'm going to do is calculate the same things, meaning that first of all the x of I minus m, the absolute value of that I'm going to calculate, which is basically x of I minus m. So 3 minus 13 is equal to negative 10, so that's positive 10. 6 minus 13 is equal to negative 7, positive 7. 9 minus 13 is equal to negative 4, positive 4. 12 minus 13, negative 1, positive 1. 13 minus 13 is equal to 0. And 15 minus 13 is equal to 2. 21 minus 13 is equal to 8. And 22 minus 13 is equal to 9. So that is that. And then if you want to calculate f of I times the absolute value of x of I minus m, that would be equal to so f of I times this number, so that's 30, that's 28, that's 20, that's 2, that's 0, that's 10, that's 32, and that's 27. And moreover, you need to find the sigma f of I times x of I minus m. Now the sigma f of I times the absolute value of x of I minus m is equal to basically 30 plus 28 is 58, 78, 80, 90, 90 plus 50 is equal to 140, 149, and your n is equal to 30. So then this is going to be 149 divided by 30, which is something about 5, which is 4.97 to be exact. They've called it 4.97. 4.97. So that's basically, for example, how you solve this kind of problem. Now there is another thing called continuous frequency distribution, which is another way of basically grouping your data depending on the situation, which we'll talk about in the next video. I'll see you in the next video.